topic of mathematical modeling. Uh, it is voting system. First we will understand it conceptually, and then we will understand the voting system using mathematics. So conceptually we will try to understand voting system. First try to understand how many voting system. Mainly there are two, preferential and non-preferential, and then we'll understand. We will use example of preferential voting system. For example, preferential voting system can be many, but we'll understand. We'll use 3 or 4, such as plurality, border count, pairwise, and non-preferential also many, but we'll just use 1 or 2 examples, such as approval method to understand non-preferential, and then we will do some assessment. So let's get started. So first, conceptually we have some multiple choice question. The first question is why the election of why it is very easy to elect, for voters to elect senators or governors than the president. So the answer to this question is A, because president, you have to go president in order to elect president because of the electoral college. The second problem is how many fundamental voting methods are there in America. As I just explained, there are 2, preferential and non-preferential. So C. What is the plurality method? Plurality method is simply the voters can only vote once, and the candidate who receive most vote winner. So each voter votes for one candidate, and candidate with most vote, so A. Now fill in the blanks. So let's see each voters vote one candidate. If a candidate receive a majority of votes, the candidate is the winner. Now let's go to the next page. Now this is the border count method. Border count method, most to the list. So voters rank candidates from most to least favorable. Each last place vote is awarded no point, 0 point. Each next, this is important, keep that in mind. The last place means 0 point. If you don't keep that in mind, you will not be able to solve the problem that we'll solve in a few seconds. Each next to last is awarded 1. So if this is 0, this is 1, and then this is 2, and then this is 3, so on. So this is 2, and so on. The candidate who received most point is the winner. Okay, fill in the blanks. Final one. Pairwise comparison. So pairwise comparison, voters rank candidates from most to least favorable. Each candidate is then compared with each other. If candidate A, for example, if candidate A is preferred to candidate B, then A receive 1 point. If B is preferred to candidate A, then of course B receive the point. Okay, now we're gonna move to the part 2 of the booklet. The part 2 is understanding American voting system using mathematics. For example, this problem is like Florida, the election 2000. In election 2000, there was a problem in Florida, and then this problem will allow us to understand that problem. So in Florida, there we have more than 3 people on the ballot, but we will focus on 3 people: Mr. Bush, Mr. Gore, and Mr. Bachanan. So Mr. Bachanan received 3,000 votes in Palm Beach area, which has approximately 500,000 votes. We'll use this information to predict how many votes he supposed to get in the whole Florida. In whole Florida, there are 6 million votes. 6 million vote in Florida. We'll use this information to understand out of the 6 million, how many vote Mr. Vachanan would received. Okay, let's do that. So 3 over 500. So now let's say total Florida, you have 6 million vote. 1, 2, 3, 1, 2, 3. And Palm Beach, Mr. Vachanan got in Palm Beach compared to the whole Palm Beach, which is 500,000. And Mr. Vachanan got in Palm Beach, he got 3,000. So which we can simplify to 3 over 500, and then F500 is gonna be 18 million. So F gives us 36,000. So he expected, Mr. Vachanan expected to receive 36,000 vote in Florida. In fact, he got 17,000 vote, which is not even close to 36,000. He got only 17,000 vote, but people still did not like it. Why people did not like it? Mr. Vachanan got 17,000 vote. Why people didn't like it? People did not like it because the party of Mr. Vachanan, the Reform Party, there were only 300 supporters of his party, Reform Party. How can you get 17,000 votes when you have only 300 supporters of your party? There must be something wrong somewhere. And it turned out to be, yes, in the ballot system there was something wrong. So the ballot system was like this. So ballot system was like this in Florida. So this is Mr. Bush. There's supposed to be Mr. Gore. And there's supposed to be Mr. Vachanan. That was not the case. The ballot was like that. This is Mr. Bush. This is Mr. Vachanan. And this is Mr. Gore. Most people vote Mr. Vachanan not because they were his supporter, but because there was something wrong in a balloting formatting system. So this is something you're going to keep in mind before we even get started to using mathematics. Now the next example will allow us to understand the preferential model. Okay, so preferential model, you need to know how to do the ranking table. So this example will allow us to do the ranking table. So let's do the ranking table. This is 11, this is 12. Okay, let's do the ranking table. Let's to understand the preferential method of American voting system. Preferential method, we need to understand, we need to know how to do the ranking table. So we'll use this example to understand the ranking table. So the problem tells us that Mr. Bari placed the order for pizza to celebrate the last day of algebra class. So he asked the leaders of his algebra class, that is Jack, Jasmine and Joanne, to cast vote. So the scenario is Mr. Bari placed order for 3 different type of pizza: large, medium and small. There are 4 types of toppings: sauces, pepperoni, mushrooms and prawns. Now these 3 students, the student leader will cast a vote for toppings of this specific pizza, either the large one, medium or small. Okay, so what are we gonna do? We're gonna create the ranking table. So very easy. So the ranking table is, so this is Jack, this is Jasmine, and this is Joan. 1 2 3 4. Okay, so 1 2 3 4. So let's say Jack chooses the sausage, Jasmine chooses the sausage, and Joan chooses the pepperoni, because there are three type of pizza: big, medium, and small. Now say this one is pepperoni, this one is mushroom, and this one is sauces, and this one is mushroom, this one is pepperoni, and this one is pepperons. This one is a pepperons, this one is a pepperons, and this one is mushroom. Let's see who wins in this. If we use the plurality method, who wins if we use the plurality method? Well, because the sauces win is because most of the people choose sauces as the first choice. Okay, so that takes us to the next problem. So this is a ranking table. So the next problem is this one. The same problem, so I'm not going to explain. However, this is a plurality method. In the plurality method, the voter cast only one vote, and the candidate who received most vote win. Okay, so 3 pizza, big, medium, and small, and 4 toppings: sauces, pepperonis, mushrooms, and pepperoni. Did any of the ranking get the majority vote? What is majority vote over here? Let's find out. 7 plus 5, 12. 12 plus 4 is 16, 18. 18 divided by 2, which is 9. So in order to get the majority, one need to get more than 9. Is there any candidate? Is there any candidate receive more than 9 votes? No. Which topping is the plurality winner? So let's say which is the plurality winner. So candidate vote. So let's say pepperonis got how many votes? 7 votes. And then sauces got 5 votes. Pepperoni got 4 plus 2. 4 plus 2. 6 votes. Now, whose topping is the winner? So pepperonis is the winner. So A is the winner. Pepperonis is the winner. Which toppings comes second? Pepperoni is the second. Pepperoni is the second. Which toppings come last? Mushrooms. Because this is first, this is second, this is third. What is left? Mushrooms. Mushroom is the last. So M. That takes us to booklet page number 14. 14 is this one, and that's bought the count method. So this is an example of another preferential model. Voters rank candidate from most to least favorable, with the last place getting 0. So the last row gets 0. So we're gonna find the winner of this ranking table. So who is the winner of this ranking table? So let's write A, candidate, and vote. So A is 7 times 3 plus 5 times 0 plus 4 times 0 plus 2 times 0. So 21. So candidate A received 21 vote. Now we're gonna do sources. Sources 7 times 2. 7 times 2. Plus we find sources. We found sources 5 times 3. We'll find sources here. Sources we found 4 times 2. We found sources. We find it 2 times 1. So 14 and 15, 29. 29 and 8 is 37. 39. Mushrooms. Mushrooms 7 times 1 plus mushroom 5 times 1 plus mushrooms 4 times 1 plus mushrooms 2 times 2. So what do we get? 7 plus 5 is 12, 16, 16 and 4, 20. 7 plus 5 is 12, 16 and 20. And finally we have pepperoni. Pepperoni 7 times 0 plus 5 times 2 plus 4 times 3 plus 2 times 3. So that's 0, that's 10, 22, 22 and 6, 28. So who is the winner? Winner is the sauces. Sauces is the winner because sauces receives 39 vote. Who is the second win? Who is like the second place? Pepperoni is in the second place. That takes us to page number 15. Page number 15 is pairwise. Pairwise we compare A to B, B to C and C to A to understand the winner. So we have a ranking table. By the way, pairwise is also an example of preference model. Okay, let's find the winner. So let's say candidate A, B and C. There are 3 candidates. A is Adam, B is Bob, C is Clinton. Okay. Now let's say A to B. Let's say A to B. So let's first count A to B. If we do A to B, then how many vote? 2 plus, we look at here, we say 0 plus 4, 6. And then B to A, of course, B to A is 0 plus 3 plus 0. So it's 3. So A to B, the winner is A. So winner A. Now we're gonna do B to C. B to C, you see B to C 2 plus B to C 0 plus B to C 0. So 2. B get 2. Now C to B. C to B is 0 plus C to B is 0 plus C to B is 4. So it's 4. So now B is the winner. Now A to C. A to C, definitely A. We'll leave out B. So definitely A. 2 plus A to C 0, A to C 0, C to A, C to A, of course 0, plus C to A 3 plus C to A 4. So C receives, so A received 2, C received 7. So the winner is C. So what a ridiculous outcome of this election. So in this election there is no winner, because if this A to B, the winner is A, B to C, winner is B, and A to C, winner is C. So there is no winner. So that is an example of pairwise model. Now we're gonna move to a non-preferential model. That is we of course use the ranking table, different type of ranking table, and that is we're gonna use the example approval or not approval. Okay, so let's say candidate W is George Washington, X is I don't know, Y is just random name, G is whatever. These are people and these are voter. Okay, now let's say the candidate, and let's say vote, who win. Let's say candidate W, how many vote W receive? A means approval, so approval. Okay, D means disprove, disprove means no vote. 1 2 3, so W got 3 vote. Now X, let's see how many vote X got. 1 2 3 4 5. Now let's see Y got how many vote. 1 2 3 4, Y got 4 vote. Now Z got how many vote? 1 2 3 and 4 vote. So Y got 1 2 3 4 and Z got 2. So who is the winner of this election? Of course X, because X received 5 votes. So this is an example of non-preferential voting model, which of course use the ranking table, but different type of ranking table. In this ranking table we use approve or disapprove, and the X is the winner of this election. Now that's it. Now we're gonna do the assessment, the problem in the assessment. The first question is the result of this election. So this is the election, so election result, we would like to find the winner. 10 plus 8 18, 18 plus 7, 18 plus 7 is 25, 30. Is it really 30?
Yeah, it is. That's it.
Okay, so let's see. 10 plus 8 is 18, 18 plus 7 is 25, 25 plus 5 is 30. So 30 divided by 2, which is 15. A candidate must get more than 15 vote in order to receive the majority. Is there any candidate receive 15? Candidate A receive 10, candidate C receive 8, candidate D receive 12. No candidate receive majority. Who is candidate plurality winner? So let's say candidate A receive 10, so candidate A receive 10 vote, candidate vote. Candidate C receive 8 vote, candidate D receive 7 plus 5, 12 vote. So who is candidate plurality winner? So candidate D is the plurality winner. Did he get the majority? No. In order to get the majority, he needed to get at least more than 15. That's not he did, but he's the winner nevertheless. Whose candidate comes second? All right, let's see whose candidate comes second. A is the second winner. Whose candidate comes last? Okay, so C is the, of course, winner, second, third. So who is the last? Who is not on the first row? I think B is not there. So B is the loser. So B. Alright. So using border count model, who is the winner of the election in the problem 1? So now we're going to do it border count. Here we just did plurality. Now we're going to use border count. What are we going to do? We're going to write 3, 2, 1, and 0. So we have to do the math. Now let's do A first. So A is 10 times 3 plus 8 times 0 plus 7 times 0 plus 5 times 0. So A received 30 vote. Now B. 10 times 1 plus 8 times 1 plus 7 times 1 plus 5 times 2. So 10, 18 and 7, 25, 35. C. 10 times 2 plus 8 times 3 plus 7 times 2 plus 5 times 1. So 20 and 24, 44 plus 14 plus 5. Now 20 plus 24 plus 14 plus 5, so 63. And D 10 times 0 plus 8 times 2 plus 7 times 3 plus 5 times 3. So this is 0. So 16 plus 21 plus 15, 52. So the winner is C because C received 63 votes. So the winner in a border count is C. However, the winner in the plurality model is D. So D, the winner, D is the winner if you use the plurality. C is the winner if you use border count. Now we're gonna use the last one. The last problem is very simple. Is the example of non-preferential, which we use approval or not approval. So you can do this problem in sleep. So let's first see Jack. How many board? Who is the winner? So let's say Jack. Jack got how many? X indicates approval. So 1, 2, 3, 4, 5. So Jack got 5. Jasmine got 1, 2, 3. And John got 2 votes. So who is the winner? Jack is the winner. Jack is the winner with 5 votes. Who is the winner if Adam drop out? Who is the winner if like Jack drop out? If Jack drop out, who is the winner? If Jack drop out, who is the winner? Jasmine is the winner. So Jasmine. Now finally, this problem is the code 5 means this is for advanced student problem. So in pairwise we understand pairwise comparison between A to B, B to C, C to A. Comparison method, find the number of comparison when n is 10. Okay, when you have 10%. So how are you gonna do that? N is 10. So n minus 1 over 2. So n is 10 times 9 over 2. So 90 over 2 is 45. So 45 comparison. Alright, so I'll see you tomorrow. Make sure you watch this video as many times as you need. And of course, email me if you don't understand anything even after you watch video 3 times. Bye bye now.